video for part D, all the hints. Part D.6, hints for final, part 3. Last 3 questions, question number 8 through 10. First, question number 8. Given a max heap with 620 nodes whose position numbers correspond to 1 through 620. Now we consider a particular node with position number 245. What is the height of this node? First, I hope you know the concept of the height, right? Concept of the height. Number of levels comparing with the bottom level. Bottom level, all right? Yeah. So here, let me draw a quick, simple case. Quick, simple case. All right, so this one, okay? We know the bottom level always high 0, okay? So for these element high 0, okay? Then this one height 1, because there is one edge to reach the bottom. So you need to go one edge to get to the bottom. All right, so the height here, so for this one height 1, but this one, you need to go the longest path. The height is 2. This one, you need to go the longest path. So the height is 3. Yeah. So that's not the shortest path, the longest path to the bottom. Yeah. That's the definition of the height. All right, so with that definition, now let's look at this question. So let me just do some analysis. I cannot solve it for you. I just do analysis. I use the general n number, not the 620. Yeah. All right, so let me draw the line corresponding to this heap. All right, for position number, so we know the position number. The first one corresponds to 1. The last one corresponds to n, position number. Okay, all right, so then leaves. Do you know the position numbers for the leaves? Right, the leaves. Yeah, so here, yeah. Let me draw these two. Two are the adjacent positions. So this one, floor function n over 2. Okay, this, yeah, so that's the first one. The second one, position number n over 2 plus 1. Okay, so these two position numbers separate level 0, that corresponds to leaves. And next one, so here, let me draw another 2 points, critical points. So this one is n over 4, right? This is n over 4 floor function plus 1, okay? All right, so this is the level 1. Level 1 means height 1, okay? Yeah. Height 0. Height 1, okay? Yeah, position numbers in this range, yeah, here, yeah. Position number in this range correspond to height 1 nodes. This range, height 0 nodes, and so on. Okay, and so on. So you can, go level by level. Here, you need to look at which segment covers this position number, 245. So which segment. The height of that segment is the answer. What is the height of this node? Because we need to look at this element is located in which segment? Okay, segment 0, segment 1, segment 2, and so on. Okay, segment 2 and so on. Okay. So which one covers this position number? Okay, so that's the meaning of this question, number 8. Okay. All right. Number 9, max heap with n nodes that corresponds to array index from 1 through n. What is the smallest possible index? Here, the index. So index will refer, these number also corresponds to index. Indices. Okay? Yeah. Because index 0, we do not use it. We just, skip it. Index 0. So 1 through n, we use them to store the nodes. Yeah. Smallest possible index for the second smallest value of the heap. Yeah. So this one, you need to, do, here I do analysis. Hope this analysis can help you figure out the answer. Okay. Second smallest. Yeah. Second smallest, only greater than first smallest, right? Yeah. So that's the first thing we know. Only greater than first smallest. Okay. Smallest possible index. Okay. Because here we can go back to the previous diagram. Okay. Index 1, index n, right? Yeah. First, 0 segment. So you know how to figure out the 0 segment, right? Okay. Second, 1 segment. So you know how to figure out 1 segment, right? And so on. All right. So here, the smallest possible index. What do you mean small? So we want to, smallest possible, we want to push to the left, right? We want to see what is the leftmost position for second smallest. Where can we push to the left? Leftmost possible position for the second smallest value. That's the meaning. Okay? So we try to completely understand its meaning. Smallest possible, smallest means leftmost position, okay? But second smallest. All right, second smallest. So here, the key is the second smallest. Largest possible height for the second. So it's largest possible height. Yeah, because the higher the height number, then this node can go to the left, right? Yeah. Height 0, that's this part. If we can push to height 1 segment, then we can search in this segment. Height 2, that segment, right? Yeah. So we want to look at the largest possible height for this element. Can you see that? Yeah, because the second smallest element can only have one child, right? Its child, if this is the second smallest, but this child is the smallest. Second smallest. Okay? And the smallest height is 0, right? Very bottom. smallest, yeah, height. So you can see second smallest can only have height 1, right? Height 1. Height 1, right? Can you imagine height 2? Think about if you have second smallest with height 2, 1, 1, height 2, 2 edges reach the bottom, right? So then it cannot be second smallest, right? Yeah. So first smallest, this smaller than that, right? Second, third. So you can see second smallest you cannot push to height level 2 segment. Height level 2 segment you cannot push. The leftmost segment you can push is height 1. Then in segment height 1, what is the smallest? What is the leftmost position number, index number? That's your answer, okay? In height segment 1, what is the leftmost position number? Yeah. So you look at the diagram of the previous question. I draw that diagram. Yeah. So you can get that. Okay. All right. So the last question, number 10. This one. Given an array with elements 1, 2, 3, 4, 5, construct all the possible max heaps that can be built from this array. First, the max heap. 5 elements. 5 elements. We know the structure is this one. 1, 2, okay, 3, 4, 5. Yeah. Has to be this structure. Okay. Then the max heap, value 5 must be at the root. Right? Value 5 must be at root. Yeah. So then the value 1 must be at leaf, right? Cannot be internal. Must be at leaf. Yeah. So 1 can appear in 3 possible places. This is one possible case. So 1 here. Yeah. So 1 here. 1 here. 1 can also be here. Okay. Also be here. All right. 3 cases. Yeah. So let me draw case 1, case 2, case 3. Yeah. Now you need to tell me. You need to construct the possible heap. Case 1, how many different max heaps you can draw. Case 2, how many different heaps you can draw. Case 3, how many different max heaps you can draw. So you put together, that's your answer. That's your answer. Okay? All right, so let me stop here. Yeah. Try your best to get the highest possible grade for this final. Yeah. All right, so